Well, in 2008, NASA and NAU teamed up to study the unusual increase of forest fires happening in the north. The NASA-founded project known as the Arctic Boreal Vulnerability Experiment, or ABUV, is led by Michelle Mack, a professor of ecosystem ecology at NAU.
Well, Mack and her team actually just returned from Alaska with samples and data that they believe is imperative for the future of the global community. Drew Miller has the story.
In the boreal forests of Canada and the Alaska tundra, there has been an increase of the number of acres burned due to natural fires. Historically, the areas had one or fewer extreme fires a year.
We know that the high northern latitudes are warming more than 2 times faster than any other place on Earth. So where I work in interior Alaska, the mean annual temperature is almost 4 degrees higher than it was in 1950. And so that's what's leading to these fires. They're all natural caused fires, lightning caused. But so there's this general regional pattern of climate warming. But then when these fires burn and release carbon to the atmosphere, that goes into this global pool of carbon dioxide. So you think of fires as a very local effect, but they're affecting the global carbon cycle.
The carbon dioxide in the soil is different compared to the soil here in Arizona or even our neighboring states. The carbon in the soil burns hotter, and when it is released into the air, has potential for global changes.
Currently, we're interested in trying to quantify, in the fires in Arctic tundra and boreal forests, how much of the soil carbon that's combusted and released to the atmosphere is old carbon, carbon that was put into that ecosystem, that was fixed by plants and deposited into soil over hundreds and even thousands of years. And we're interested in that because it's unlikely that if that carbon is burned now, it's ever going to be replaced. So it will represent a net flux or a movement of carbon from these ecosystems to the atmosphere, which we think of then as an effect that could actually accelerate climate warming.
The studies will continue until Dr. Mack's team finds a way to control the burning of the excess carbon into our atmosphere. For NAZ Today News, I'm Drew Miller.